Hi everyone, welcome to the class. I'm Wangil Singh. Today we are going to learn how to draw a straight line graph from a given linear equation in two variables. Although it's elementary coordinate geometry, it's fantastic to truly understand how an equation transforms into a visual line on a graph like this. And mastering it builds a powerful foundation for higher mathematics. Once you see the connection clearly, everything becomes simple and logical. Along the way, I'll also share some useful extra insights so that you strengthen your foundation. So grab your notebook and let's begin. To start with, let us first understand how a general form of a linear equation in two variables look like. Ax plus by plus c equals to 0. So this is the general form of a linear equation in two variables, where a, b and c are constants and x and y are variables. So constants means they can be any number, and there is a condition that a and b cannot be 0 simultaneously. Both of them cannot be 0 at the same time. So one of them can be. So I'll give you an example of this kind of equation. Let's say, right, this is similar to this, where a is 2, b is minus 3 and c is 1, right? Another example, now see, this is also a linear equation in two variables in geometry. Although you see the, the equation is made up of only one variable, but this comes from here only. Let me show you how. So here your a and x part is missing. So this equation can be rewritten as 0 into x plus 2 into y minus 5 equals to c. Now even this equation looks like this, isn't it? Your x is there, but the coefficient of x is 0. That's why this part is missing. So this equation also represents a straight line, which I will show you later. All right. Now let us begin with our work, the actual work of representing a linear equation in two variables by a straight line. Okay. To begin with, I I would like to tell you that you might be wondering, where does linear equation in two variables come from? Okay, let me give you a situation. Think there were two brothers. Okay, let's say the name were Asim and Sam. Let's say Asim is 1 year older than Sam. Asim is 1 year older than Sam. You don't know Asim's age. You don't know Sam's age. So let's say Asim's age is Y and Sam's age is X. So what I said, Asim's age is Asim is 1 year older than Sam. So it can be written as Y is equal to X plus 1. Isn't it? Asim's age is 1 year older than Sam. So this equation I can write as x minus y plus 1 equals to 0, right? So the word problem, when I represented the word problem in terms of equation, so this is the equation in two variables. So this is how a two variable equation comes from. One of the ways, there are many ways where finally you come to this situation, but this is an example. So now let us draw a straight line of this equation. Okay, so the equation is x minus y plus 1 equals to 0. So before we start, a few things I would like to tell you is that and this, let's say this is a graph paper. By the way, you must imagine that this is a graph paper, and on it we have drawn the axis, the x-axis and the y-axis. Well, this part is known as x dash and this is your y dash, negative y-axis and negative x-axis. This is our origin. Okay, any point on this graph, this is called a Cartesian plane. Okay, by the way, any point on a Cartesian plane is called coordinates of the graph or coordinates of the plane, and the coordinate is an ordered pair. So what does that mean? That means the coordinate, let's say here I have a coordinate, then this coordinate is represented by x comma y. This is called an ordered pair. Okay, or x comma y, or let's say a comma b. The first one is called x coordinate or abscissa of the point. Let's say the point is here. A is called the abscissa or x coordinate of the point, and B is called the y coordinate or ordinate of the point. This is called y coordinate or ordinate. This is called x coordinate or abscissa. Okay. So for example, if you have to plot minus 1 comma 0, let's say minus 1 comma 2. So we want to plot this point in this Cartesian plane. So x part is minus 1. Okay, so x part will say that the point will move on the left and right side of this graph, while the y part will tell us that the point will move either up or down. So x is minus 1, it starts from 0, minus 1 is here, okay, and y is 2. So 2 is here, so it will go here above. This is the point minus 1 comma 2. So this is how we plot a point in the graph. So I hope you understood. Next important thing is to understand that any point lying on the axis, either on the x-axis or y-axis, um, you know, it has a general form. Let's say any point lying on the x-axis, let's say somewhere here, this line is given by x comma 0. X means any point here. It can, if it is here, it is 2. If it is here, it is 3. 0 means it's neither going up nor going down. The height part is 0. So y is 0. So any point lying on the x-axis, your y is 0. So if a point is lying here, the coordinate is minus 3 comma 0. Similarly, any point lying on the y-axis, your x part is 0. This is 0 comma 3. If you come here, it is 0 comma minus 2. Because look here, 0 means it's either going here or here, right? So it's going nowhere, so it's here only, it's in the origin. Minus 2 means it will come down here. So this is the point 0 comma minus 3. Similarly, this point 0, it's at the origin, it's neither going on the left or right, and 3 means you'll have to come up, and this is the point 0 comma 3. So understand that any point lying on the x-axis, your y part is 0, and any point lying on the y-axis, your x part is 0. So let's come back to our problem, that is, drawing a straight line out of this equation. So how do we do it? I suggest you to keep one of the variables on one side and send everyone to the other side of the equal to sign. So here I'm planning to keep x on my left and send the rest to the right. This right. Now using this equation, I'll find the values of x and y. I will find three values of x and y. Okay. So for every y, I'll get a value for x. And you can give any value to y, any real number. Okay. So first I am giving y as 1. If my y is 1, x is 0. Another I'm planning to give, let's say y is 2, my x is 1. So although I can give any value to y, so for which I will get the corresponding value of x, but I'm not giving too large values for y, like 100 or 200 or 1000 or 10,000, so that my x values are also large, and ultimately that won't fit in my graph. My graph, look at the numbers here. On the positive x, it goes till only till 5. My positive y-axis is only till 6. On the negative side, it's only till minus 4 and minus 3. So I'm not planning to give big numbers, right? Another is I'm also not assigning fractions to y, fractions or decimals. Even if I give a fraction, I'll get, okay, one you can try. If I say y is half, if my y is half, then x is minus half, right? So likewise, I can give any number, but plotting half is easy, although half is easy, but plotting some other typical fractions like 0.83. Okay, so plotting those kind of points will be, uh, you know, challenge for us in this graph. That's why I suggest you to give integral values for x and y. Means give integers, either positive numbers or negative numbers, but give whole numbers. Okay, so we are using these 2 points. Means from the graph, from the table, I can say 0 comma 1, these two, x is 0 and y is 1, and 1 comma 2 lie in this equation. Although this one will also lie, this minus half comma half also lies in the equation, but I'm using these 2 points to plot a graph. You only need 2 points to join a line, isn't it? So that is why I'm using these 2 points. Okay, let's find 0 comma 1. So x is 0, y is 1. Okay, this is the point 0 comma 1, right? This point. And the next point is 1 comma 2. X is 1, y is 2, right? Somewhere here, let's say this is your 1 comma 2. I hope you can see. Now if I connect the line, okay, say if I connect the line, then it's fine. Now if I bring it down, do you know from where exactly this line intersects the x-axis? Is it going to cross the -1 mark, or will it exceed this point? Is it going to come here or here? We don't know, right? If I was, if I were doing this in a graph paper and my intervals were exact, then connecting these 2 points and using a scale and drawing it, then it will pass exactly where it should go through. Okay, but since this is an approximate value of the exact graph, so I cannot, I cannot be sure that it will pass through here. So in order to be sure, I have to check from this equation only. So what I will do is, if this line is, ultimately it's passing through x-axis, so any point, so the if it passes through x-axis, then a point will be there on the x-axis and the line, right? So any point lying on the x-axis, what did we learn? If it passes through the x-axis, then your y part is 0, right? So if your y is 0, then x is how much? -1. So -1 comma 0, this point also lies in this equation, that is this point, right? So now we are sure that this line also passes through this line exactly passes through -1 comma 0. So although this line extends till infinity in both the sides, but we'll draw how much ever it fits in the graph. Okay, so this is the line from the equation x minus y plus 1 equals to 0. So this is how we construct a line. And the points that we found, likewise we can find how many points? Infinite number of points. That you can imagine the points lying in the line, or you can think it this way also, that this line is made up of infinite points. If you join small points, each point ultimately when you zoom out, it will look like a line. So that's how you can think of this line being made up of small points, each points. So there are infinite points in a line. So these points or these coordinates are also called solutions of the equation. Understood? What does that mean? Solution in the sense, if you substitute these values, these points in the equation, then left hand side will be equal to right hand side. Choose one of them. Let's say I'm choosing this 1 comma 2. So if x is 1 and y is 2 plus 1. So this 1 plus 1 is 2, 2 minus 2 is 0. Now you can choose any other point. Let's say -1 comma 0. If x is -1 and y is 0, so this is 0 plus 1. So this is also 0, which is equals to your right hand side. So that's why any point lying on the equation, they are called solutions of the equation. All right. Now I would like to show you one more equation. From it we'll derive a graph, and that graph also I'm going to plot it here only. Okay, I have brought another equation from which we will draw a line for this equation. Okay, let's do it. Similar to the previous one, we will keep one of the variables on one side and send everybody to the other side. So here also I'm planning to keep x on my left and send the rest to the right. Okay. Now using this equation, I will fill a table and then find at least 3 points. 2 points is okay, but 3 points means I will find at the x coordinate and the y coordinate. Okay, where does the line pass through at x and y? In between we can find any point. So okay, for every y I'm getting some value for x. So if I say my y, I want to make y 0. The moment I make y 0 means the point is going to lie on the x-axis. So if my y is 0, then 12 by 3 it's 4. So the point is 4 comma 0. So this is the point 4 comma 0, right? Next, let's make x 0. If my x is 0, then this will come here. 0 into 3 is 0. I'm doing it here. Okay. If it is 0, x is 0, this will come here and become 0. I have 12 minus 2y. So it is 2y equals to 12 and y equals to 6. So if my x is 0, y is 6. Right? Third point. Can you think of a third point? Although 2 are enough. So 0 comma 6 is this. The moment I say x is 0, the point will lie on the y-axis. So this is the point 0 comma 6. X is 0, y is 6. So you come up, so it is 0 comma 6. So if you connect these two lines, these 2 points, then okay, let us find one more point. X equals to, let's say y is 3. If your y is 3, then this is 6. 2 3s are 6. 12 minus 6 is 6. So 3 into 2. Right? 2 comma 3 is the point. Come here. This sector somewhere. 2 comma 3. So this line passes through 2 comma 3 and 4 comma 0. Although it's not straight, it has to be straight. Okay. So please make sure in your graph paper it is straight. So this is the equation. This is the line represented by the equation 3x plus 2y minus 12 equals to 0. Alright? And similar to the previous one, the points 4 comma 0, 0 comma 6 and 2 comma 3, these 3 points lie in this equation that we have seen it, right? And these 3 points are the solutions of this equation. And what was our previous equation? This is our previous equation, right? That is x minus y plus 1 equals to 0. So what I did is I drew 2 lines from 2 different equations and they are intersecting at a point. The point of intersection is 2 comma 3. Okay, so the point of intersection, it's so interesting to know one thing about this. When the 2 lines intersect, the point of intersection is the only point which is a solution of the pair of linear equations. So we call it a unique solution. Means these 2 pair, if you solve them both simultaneously, then you get only one value for x and one value for y, which will satisfy both of them. Okay, algebraically you can do it, but graphically if they ask you to solve the pair of linear equations graphically, then this is how you do it. The point of intersection is the solution of the two equations. So 2 comma 3 is the solution for both of them. Neither this nor this nor this nor this, none of them are the solutions. This is the only solution. You can put it in the equation and check. It will be left hand side will be equal to right hand side. That means if you put the value of x as 2 and 3, everything should come 0, and if you put your 2 and 3, it will be 0. All right, so that was something really fascinating to know. And another, they can ask, they can add something more, like find the area of the graph formed by the two lines and the x-axis. So area is given by what? Half into base into height, right? So how much is your base? So it's so our base is, look here, this is the base, right? So it's 1 unit, 2 unit, 3, 4 and 5. It starts from here till here, 1, 2, 3, 4 and 5. So base is 5. And the height of this triangle is the, no, this one. The highest height. This is equal to how much? It's 3. So your answer is 5 3s are 15. It's 15 by 2 unit square or square units. Since area is written in area's unit is square, so that's why we don't know the unit is centimeter or meter or whatever it is. So we write like this. So this is the area of the triangle. So okay, we come to the end of the video, but before I end today's class, I have one more equation to show, which we had discussed in the beginning. An equation like this, let's say x equals to minus 5, or let's say y equals to, let's say x equals not minus 5, let's say x equals to minus 3, or y equals to 4. Okay, so even these kind of equations represent a straight line. This is x equals to minus 3. In geometry, it means this. Where is our x equals to minus 3 is the point here. So the line represented by this equation is this is x equals to minus 3. Likewise, if it was x equals to 3, 4, 5, any line, then you'll draw lines here. So x equals to any number, let's say positive or negative, that line is always parallel to y-axis. Right? X equals to minus 3 is here, x equals to minus 2, x equals to minus 1. So what about here? X equals to 0, isn't it? So that's why equation of y-axis is x equals to 0. Because even y-axis is a straight line, so it has an equation, and the equation is x equals to 0. And similarly, let's go for y equals to 4. So where is y equal to 4? This is the point 4 on y. So the line which passes from this point, this line is y equals to 4. And y equals to any number, let's say minus 2 is this line, minus 3, minus 1. So y equals to a number. Okay, so that kind of line is always parallel to the x-axis. Similarly, y equals to 1 is here, y equals to 0 will be here, isn't it? Y equals to minus 1 is here. So y equals to 0. That's why x-axis, its equation is y equals to 0. The straight line x-axis, its equation is y equals to 0. Okay, and that's how we represent a linear equation in two variables as a straight line on a graph. And I hope this made your concept clear and easy to understand. Practice few more examples on your own and you'll master it in no time. If you find this helpful, do not forget to like, share and subscribe. See you in the next class.